Before I give you my demo, I have to announce what the project 2 is. So, and we all kind of like stories. So I have a backstory for this too. So I was talking with one of my colleagues and he kind of said, hey, you know some stuff about Internet of Things. I have a challenge for you. And after he explained it, I thought, oh, that's a great challenge I can actually forward to my students. So my colleague has a boat. And he thinks kind of living in a normal house is kind of stupid. So he lives on a boat. And so he kind of, like me, he's traveling all the world. And so he wants to have maximum convenience on the boat and thought, okay, some technology could actually really help. One of his big challenges is how to know how much liquid is in each of the liquid containers in his boat. So he has gasoline. He has dirt water from kind of the water which has been used from the toilet. And he has drinking water, and there is also water for the air conditioning on the boat. So now is the question, how can we figure out how much water is there on a moving boat in each of these containers? And so we actually have various devices how to measure amount of water. And so you have to figure out the best way in project 2. So you have to kind of make a big table, kind of look at different sensors and maybe invent some sensors yourself and say how suitable they are for different types of water in different ways of movement. So basically I want you to make an experiment on testing it with fuel. So I ask you to use some kind of vegetable oil for this as a simulation. Wastewater, I think you will be able to make water dirty. I think that can be done for cheap. Fresh water should also be very easy for you. And yeah, and basically this is the same type of water you need for the air conditioning or heating. Yeah, and then you want to try the different sensors, at least. You want to try the scale, you want to try the different distance sensors we have. You want to try this guy here, which I will show you later, which is a rainwater conductive sensor. And then you want to try various kind of binary devices, which just say you it's empty or it's full, based on the reed switch or one of these tilts or some kind of yeah. There are others which kind of will kind of, if there's enough weight or so, will then actually click or use the Hall sensor with a magnet. So that at least find 2 others where you can actually binary measure this. So this is also why I present this already today to you, because you want to bring some props. So I already see you all have kind of vessels, and maybe we can actually even reuse what we just got as a gift today to turn into something. But that basically means we need 3 bottles, approximately, containers which you can make dirty, or to try to gather some plastic bottles, or look at home to bring at least 3 containers per team. Then get some oil to play with, get some dirty water. Bring a magnet from home so we can use the reed switch. Bring some kind of things to be creative, so something which swims, cork, or anything else which swims in water. Get some glue and some scissors so we can actually be creative for the project. It's not today, but for tomorrow you can start with project 2, so to build different contraptions to see how best we can measure water on a boat or liquids on a boat. Yeah. Okay, and the end result is a table and several recommendations to say, okay, this combination would be good in real life, but not so good on a boat, or yeah. So I want to have lots of critical reflection in the end, which I then could tell my friend what he would actually use best on a boat. Yeah, he says there's actually tremendous opportunity. There are lots of people who sail, who have boats, and you can actually sell things quite expensive to them. So if anybody wants to make a business in providing Internet of Things for boats, I think there is a pretty good business opportunity here. So finally, and I think something in terms of fate really wants me not to give this demo, but we will try now to actually have this. So you have to help me a little bit. I wanna, so first, of course you have to work during this, but also please help me in keeping this order here, yeah? So I want actually to show you how to connect the relay, how this trigger stuff works, show a little display, show some analog measurements and how this can turn into graphs and charts. And if we still have time, show you also the connecting RGB LEDs and RGB strips. And everything with ulno IoT. So you have seen how to flash serially a ulno IoT device. Do you remember what the magic command was? It's initialize serial. Yeah. So, however, I think actually if you type initialize and help, it might say this to you. Yeah. Oh no. But it doesn't say serial here. Okay, forget what I just said. Make an issue that I update this documentation. Okay, so we have this guy. So I pre-flashed these, and I showed you last time how to flash one. But the next thing I really have to show you is how you can adopt it. So sometimes you have built things in, and you don't want to connect it to the computer and flash. And you know I hate flashing. So one of the big reasons I invented this system is to prevent flashing in class. So even if I let you now do all the flashing, I will now show you how to prevent doing it. And for that you need a flash button on the device. So this is why I always make you wire the first button to D3. Yeah, D3 is the flash button. It is usually pin 0. So what I will do is I will wire this so that ground here goes on D3. Ground on D3. And so when I switch this on, so basically when you reboot, you see it will actually do some blinking. So you see that? So the first 5 seconds when a ulno IoT firmware device starts, it does a 5-second blinking thing. And that's basically an notification for you which shows that now you can still make an action, and the action you can do here is actually, let's plug this in again, press the button twice. So when you press it while it blinks twice, it will go in some kind of Morse code thing. So probably you see this now. So now you see it kind of does a couple of long blinks and a couple of short blinks. Let's count 1. So it's 1 and 5, if I see this correctly. 1 and 1, 2, 3, 5. So it's 1 and 5. So usually you would now take your phone to connect to an access point. So it's now in a mode that it can be adopted. So basically you can move it in a different Wi-Fi network, and then you can reset the key on it. So we will adopt this device now. And for this we will open, oh great, where is the other Ethernet? There. So you see now here there is an access point open which has this Morse code at the end. Yeah, so can you see that? So ulno IoT node DF15. So if I click on this, I can connect with it. If you open it with the phone, you will get, like in the airport, a catch-all, and it automatically asks you to sign in. If you do it from a computer, you have to actually open the website on this device. And the website on the device is 192.168.4.1. So usually on a phone that should happen automatically, and you should come to this configure Wi-Fi page here. You see there are all the Wi-Fis this little device here can see. And so I can now go here to my IoT Empire, which is the Pi I have here, and log in there. Stupid IoT Empire. and then I save that, then this connection should actually, so it stops blinking, stops doing the Morse code, and it should kick me out. Come on, kick me out. Good. Now I have to go back to my normal network. And now it's basically ready for receiving new keys and an initial firmware, which you kind of do with initialize without any parameters. So usually you just need, if you adopt some things, initialize, and there's another command we need to kind of reflash things, which I think we have seen last time, which is deploy. So usually the only two commands you need are initialize and deploy, and sometimes you need initialize with serial. So this guy is test2. So let's not confuse things. Of course, you can then easily adopt the wrong one. Initialize. So you see, it's connected to my battery. So I put a new firmware on a device now, which is not connected to the computer. And that puts the new key and everything on there, even if it was initialized before from another student. So you will have to do this a lot when you merge your teams later. Authenticating OK is already pretty nice. If you reset this, it goes back to the status it was before. So if you disconnect the power, then you have to start the process again. So, done. So now we have them all in our network. Now I have 3 devices to play with here with you. So you always want to have success here. So what is the next thing I wanted to show you? I think how to connect the relay, yeah? Okay. Minus plus signal. Okay. Let's do this. Need some cables. So you know the spiel. Put it to ground, and the relay needs 5 volts. And we need a free port. So let's use D1. So we take minus is here. Plus is here. Okay, so we are on test 2. And let's edit this. What do we need now? So I connected the relay with the signal to D4, D1. How would the command look like I have to edit to add here? Woo! We have to work. Yeah, so if you're unsure, check the help. To look at these commands, you can also, you guys can also use the help here. See, there's a help right here. And here are all the commands ulno.IoT supports. And so what could be it? For example, could be an output, yeah, or out or LED or so. So, but basically we need output. Basically we need the same command we had before. So let's therefore go back to the editor. And copy that one here. So this is our relay. Let's call it R1. And this is on D1. And so this doesn't need any special commands, but we want to have it off by default. So, okay, this is saved. And remember how to put it on there? What were the two commands? Initialize and deploy, yeah? So deploy. Because initialize it is already. So you just say deploy. It's recompiling, but I think you know that it takes even longer on the Arduino IDE. If you install ulno IoT on a local computer, it gets even faster. So the main thing is this dependency detection. The Pi is not the fastest computer out there. But now it's compiled and uploading. So there's an easy way to test this, which we have seen last time. So you can actually use MQTT send in here, and then it sends a command via MQTT. And we call the relay R1, and these outputs always need a set topic. And so let's see if we do on, if it works then. Yeah, I don't know. See that? And we send off to switch it off. So that's basically the effort to make an output work. So what's the next thing I wanted to show? So we have seen how to adopt it. We have seen last time how to flash it. We have seen how to adopt it. We have seen how to update it via deploy. So now we want to see different devices, and the first one was the relay. So let's do the trigger device. What is a trigger device? Let's read about it. Up. Go back. Oh, it's not documented. Oh, great. That's weird. I had that before. Okay, let's do something first which is documented. Let's do analog first, and I'll show you the trigger next time. So trigger device, just for saying, is something which counts the numbers, how often something goes high. So if you have a shock device, and there you have in your sensor kit some things where you can actually see when you shake it that there's something moving in their little mercury ball or so. Then this you can use for the trigger to count actually how often a flank is going up or down. Okay, we do, it's not called trigger anymore, it's called edge counter. There it is. So let's do it. So let's take the edge counter here, and let's find a device where we can do that with. What do I have here? Whatever. Let's take another button. And how to wire that one. Put that here. Need some more ground. So, and we put this button on so let's get some ground. Same as here. Ah. Anywhere. And we take this to D2. So let's make this one on D2. And then again, we have to edit this one here. So we have it now on this. Why this is always coming an error message here, I don't know, it still works. So edge counter is set, and so how do we get it on there? Remember? Deploy. So we want to record this somewhere, so let's go to Node-RED, and we have to log in here, IoT Empire. This is our test one, very good. So let's clone this node here, and we call that V1. Let's disconnect this here and connect that so we can see what is going on. Let's see the debug. Oops, it's not test 1, it's test 2. Let's see if the slashing was actually successful. Error is not good. I have done something wrong with the edge counter. Name and pin. And then we want to measure rising edges. So let's see again. Name and pin and rising edges is default. Okay, easier. Deploy. This looks better. Yes. Okay, so let's hope we have this one up there now. Wrong. Node-RED. There, see? It now slowly counts up with all the, because I'm pressing not very nice, I usually trigger more than one rising flank here. So you can use this if you measure some kind of shocks, or you can use this for the read switch to actually see when it really goes by. Now see, I press quite often. So that's this. Next one. What else do we need? Display. So I've connected actually a display here, and it's already doing some stuff here. So I'm actually using the Now let's connect the display and connect it with the distance sensor here, that it actually shows the distance right away on it. But let's first do the display and send something to the display. This display is wired to normal I2C, and let's check out here test 1, because I think I prepared this already. See, there's actually the display, and this is all you need to do. So this is just a display name. D1 is so we can call it DP1 for display 1. Yeah. Now let's do actually font large, because else you guys will not see anything. So it's the same as the, so there's it's another display. You guys don't have this display, you have the 8. So if you look here at the manual again, there's this display 44780, which just is explained in the normal display. And so here you see basically this is the display used in class. So, and I have a small I2C display. They're very similar. Yours has only 2 lines. This is the bigger display, and sometimes you see these smaller displays here, which are more graphical, which you can actually have more text on there. They're cheaper. So we will use that one. And this is in test 1, so we should be able to just deploy this one now. Yeah, please. That's
have you thought of building like a user interface for that whole thing?
Yeah. So basically, it's only 2. Yeah, as you see, there are basically 2 commands left, which we put in here, and my vision is actually to put it completely under Node-RED, that you have some kind of little web node there where you can kind of say where to do that, deploy and initialize. Concerning the programming, you have to decide yourself. So I will show you a little later today how you can add filters and do some real programming in there. So I'm kind of torn there if I want to actually let people kind of configure that in a web interface and just have the devices in there, or if I want to push the programming still on them. Because you lose a lot of the local interaction if you don't do that. But you decide yourself. So when you see that. I agree with you, the initialize and deploy would be nice to have some even more graphical. Basically, you need more capacities in students working with me, then that would be all done quicker. So we have deployed that is good. So now we should be able, so the display is empty now, as you see, and now we can send something to the display directly. I will use this again. So we'll do it. When you use MQTT send here, you can also use Node-RED to send it via MQTT, but this is just for testing here, DP1. And so if we send, I don't know if you can see, there is a little hello now on, you see a little white writing here on the display. So, and if I send another hello, it will go to the next line. So you see now that there are several hellos on there. So that's basically what you need. You can actually send a special command. So you can do a clear. So if I do that, you will see that there's not only one hello left on there. And with this, you can You can also do a clear and then a go to. So then the hello is kind of in the center. See that? So with this, you can use this easily to kind of position things and kind of and show that. And that works also for the display you guys have. It's the same way of using that. Okay, so that was the display. And now let's do the distance sensor, and then I show you how to connect these locally so that it works basically without Node-RED. And that's where your point comes in. Do we want to, or can we even specify that in a web interface in a nice way? So same thing here. Again, we would now look up what is the distance sensor, but I have prepared this already. So go just back into the setup. And this is this HCSR. So that's actually the name which is written on this little module with the eyes. I don't know if anybody of you use that. It's an ultrasonic sensor which sends out a signal and measures how long it travels back to you. So we'll do a lot of work with the liquid stuff with this, because it's pretty good to actually even find the distance to the top of a liquid.
But it's actually not low, like high range, isn't it? It's like just for 3 meters?
3-4 meters, yeah. Same as the time of flight sensor we have. I don't know if you want to measure longer, you need kind of real laser as and reception. So this device is €2. Then we have a time of flight sensor, which is a little laser and which can measure that back, which is around €10. And then what you are talking about is about 50 to 300 euros if you want to have longer distances. But you can still find it. Problem with the lasers is always if there's really bright daylight, they often can be distracted by it. So you have to eventually do some filtering, and so that makes it a tiny bit more difficult. Save that. Did we save this really? Yes. So let's deploy. So I just recently actually made this web terminal here and the browser. So before you had to do everything in the terminal. So I think that is one step in direction becoming a bit more graphical. So we did the display, and now we should have the distance sensor. And so let's see that we can measure this in Node-RED. Remove that. And so this is test 1. How did I call the distance sensor? Do you remember? Oh, distance. Okay, so we want to actually get here test 1 distance. And why not actually visualize that? So I also promised you to show you some ways to use Node-RED to turn that directly into some graphs. So we take a gauge and we take a chart. And then we have to make sure that these are both in our test, because by default they're done. No? Where did they end up? test. Test. Good. And maybe this already works. Check it out. We have to look in our test. There you see. And so if I now actually come closer, you see, we should probably in the gauge say that it is a little further. So let's say in the gauge, this goes from 0 to 500, or actually 4 meters or so. Do check the test here, yeah. Huh? Okay. And here you can see. No, this is not. No, I think I miss actually. So this is. Are you right? Maybe I'm messing up the units here. 4,000, yeah. Okay, so it should go up when I point it up. No. No, it should go until 4 meters. I don't know why it. Huh. Seems like it hits after 40 centimeters. I have to see what is going on there. Strange. Is it correctly connected? D6, D7, yeah. Should work. Okay, well that's not the most important thing. I wanted to show you how now I can connect this, so it basically shows on the display the distance without going via the network. So we have to go to the setup here, and actually you want to take a look at a full example first. So let's go here to somewhere else. If you go into IoT Examples, there you see the running node test, and there's basically everything in here you can do. And there you can see that there are some commands which allow you to put a callback on there. You see here is actually with on change callback. And now I can take this, go to our setup. This is test 1. And now we want actually to move this here, and we take this one down because we have to, in the distance sensor, use that one. So we want to use this change callback here. And so we want to get the stuff from the display, from the distance in there. So there's if we want to access internally one of these variables we have assigned here, the distance, then we have to use this here. So in distance, but we want to also use the display, and we want to print something on this display. And let's put in there clear, and then let's print on the display the distance value. All clear what I'm doing there? So this is a C lambda expression here. And so we can basically give so this is the lambda or closure in C. Basically this is the function I give as a callback here to this device. And so basically anytime this device has a change, it will call this function. Okay, it's saved, deployed. And this is, I think, pretty hard to do graphically. But you see, it's kind of similar to the Arduino IDE, but still, you kind of have to think a bit more in this new object-oriented terms if you want to build something here. There we go. And let's hope I didn't mess it up. It's booting. And okay, I messed it a little bit up. Must have not done the clear correctly, because I see a lot of clears now on here, but you can actually see that it kind of, depending on what I do, changes here the display. Ah, actually I know. The command clear only works via MQTT. If we do that normally, we have actually clear command. We can do, instead of this, stupid me, this is what we want. Okay, save that, deploy. And then it should also clear the display all the time. Here we go. Flashed. This guy is rebooting now. Please. Yeah, no, it's. You can always see the flashing in the beginning when it reboots. And now, yeah, now we can see just one line on the display which shows the different distance here. Good. So that's how you connect things. You can, with this callback, you can do things like it switches locally. So if you want something which just, you have a relay connected and a button that you can switch the relay also locally. There's one more thing I will show you. You can also add filters to it. So for the analog stuff, you can smooth things and can have some filters. And that's where we run now, because I promised you to show you the analog stuff. So let's do, for the analog example, this water sensor here, and we will dip it over there into the water which sits there for cleaning. So let's connect the water thing. So this is an analog sensor. So I have to wire this. Let's wire this to. Where's my small battery? Here. Let's wire this to this guy here. You have a mini breadboard here. Put that on there. And I need 3 cable. I will need ground. So with the analog sensors, always be careful with the voltage. Again, better use 3 volts to feed into there. And I will connect this to D6. No, to analog. So some of you have used the analog sensors already. Very important that you wire it to the A0 port on here, yeah? There's only one analog port on these devices. So that needs to be A0. And where did I put this? Here. So A0 is on gray. Signal plus is white. Good, so this shows a red light, so it seems that I have wired this correctly. So same spiel. You want to check out how analog works. So just check out the manual for analog. And as you see, the water example is already in there. We copy that. And I will now add it. This is the node 1. Okay. So we'll just make an analog water. I have the precision. The precision is actually saying only how much it has to change to report, and as it reports 1,000 values, up to 1,000 values, I usually give a precision value, so it reports a little less. So only if I have a change of about 10. So we have to deploy this one. So it always knows when you're in the right folder where to send the data. That will come in handy when you have lots of devices. You can also call the deploy on the, great. Yeah. Don't use any quotation marks because it generates the internal and external name both. So this is how it works. Didn't like it. Let's try it again. So there's one thing when we, here. So you can actually also with the analog device kind of attach so-called filters. See, you can actually smooth things, make an average value, and this is also something where you use one of these lambdas. And there are a couple of pre-prepared filters you can try out too. So that might actually come in handy when you do the distance or the water measuring to actually smoothen things. So you might want to play a little bit with these filters. Let's see if it success. Very good. So let's now see what values this guy is reporting. I will just change this. So we had the distance sensor before, and this is node 1, node 1 water. This goes only until 1023. Okay, so you should even see now when as you see when I touch it with my fingers, because my fingers are a little sweaty, it goes up here. We should see if we dump this into water. Something more different. Yeah. Okay. That's how this works. There's one kind of neat feature, because basically sometimes if you just want to measure is water there or not, so you can actually see the deeper I dip it in there, the higher the value. So you can use that later for your liquid testing. With water that works pretty good. With dirt water it works even better. And with oil I think it doesn't work at all. Let's go back. So the nice thing here is also sometimes you want to just do it digitally. This is for this, what this threshold is for. So if you add this here, it will report if it's over 100 wet, and if it's under 100 dry. Yeah, but I won't do that now because I wanted to show you also the RGB LED. Let's disable this stuff and put the RGB LED instead here. Here it is. So the RGB LED here, so there are two types you often will find. You will find this LED strips and simple LEDs. So the LEDs usually have 4 inputs. One is power or ground, and the other 3 are red, green, and blue. These strips are usually a little bit smarter. Some of them also have the 4 inputs, but often you have only 3. If you're only 3, it means you can control each LED on its own. So there's actually a data, it's like a one-wire protocol to control all these LEDs. So I will first show you the simple one, because in principle both of them you can use in Ulno IoT the same way. So we need some more cables. About 4. 1, 2, 3, 4. And so I wire them all up. The problem is usually they write something like RGB on the LED, but often it's wrong. So you have to play a little bit and figure out what is really the red line, what is the green line, and so on. Let's make it the other way around so you can see actually what I'm doing here. So this is So and some of them are inverted, so that's also a problem. I think the big one you have in your kit is actually an inverted LED. So, what is ground? This is ground. Ah, I can actually just plug this one in. So, and this is these 2, 3, and 4. The 2, 3, and 4. So I have to look up again how I do that. So that is a single RGB. So that is here. And let's take this as an example. So you see here's already it's not very orderly there with D3, D4, D2, but I think that's actually the configuration of this specific LED. So we do this in RGB1 and deploy that. RGB single. You can read about RGB multi for the next thing I actually will do here. If I, yeah, we have still 5 minutes, yeah. Waiting for device. Ah, success, very good. So if you read the manual, you can see that we can send now actually colors to this. And so this is RGB1. We can now send to RGB. I don't know, is RGB set? What does it say in the manual? No, ah yeah, here. RGB1, RGB set, okay. Send, let's try to send red there. D2, D3, D4. This should work. Maybe this LED is broken. That would be sad. I called it RGB1, didn't I? RGB1. No, that is node 1, so that is why I have to give it the...
Yeah, but you sent to RGB1.
Let's see what it said. You see it sends to node 1, RGB1, RGB set. So that is actually correct. So let me try a different LED. Don't have any. Okay, I need to prove now that it is broken. So you can always test the LEDs manually, these ones, because you can just wire things to ground and power, and then see the single LED and see if it lights up. So if we have ground, this is purple, And so let's try to wire this to 3 volts. Yeah, that's what I was suspecting. I think that is fried. You don't have an RGB LED, don't you?
I have one.
You have one? Yeah. Can we try yours? Yeah, I think the LED strip I'll show you another time. Oh, this is an inverted one, great. So we have to reconfigure. VCC. Can you look up in the help? I think I have a parameter to invert it. And tell me what this is. VCC. Okay, this one works. And let's check. So I haven't. Let's send to this. So if I send black to it, it should actually be white because it's inverted. Yeah, see that? So if I send white to it, it should be off. So we can also send an RGB value in there. No, depending how so no. To get a clear color RGB, I need to make 1 0 because it's inverted. So see, this is red. So if I do this, it should be one of the other prime colors. And then it's this one. Hardware, so because they decided to make it this way. It just exists. So there's an option to actually switch on the inversion in ulno IoT, but I have to look it up what it actually was. It's not in the documentation. It's a secret feature. And then you can just use it normally. But you see, you can just use the values here to actually figure this out and just send it there. I will show you the strip the next time, so I have to pack up now. I hope you have got an idea. And today in the lab, don't run away yet. Very quickly what you have to do today. Do what you've done with Project 1 in your IoT. You just convert the whole thing. If you don't find some of your devices, talk to me and we'll see if they are implemented in spite of not having documentation, or if we have to find a workaround. But it should not take you very long to transfer to your IoT. Be careful. I also have to talk to you about Project 1 in the native way. So you don't want to reflash everything right away. Maybe just toy with one VMOS so you can come back before I work with you. Good. Thanks. Sorry for being late. Yeah. See you in the labs.